So the quiz is only over section 3.3. In this, we did two different things. We had those limit problems, and we had derivatives of trig functions, right? So if I gave you something like the limit as x approaches 0, tangent 4x over 5x. When we did these limit problems, what was our strategy? Right. If we could get like sine of something over that same something, we know it went to what? 1. Can you just plug a 0 in here right now? Because it's 0 over 0. So we could change tangent into sine over cosine. This is like 5x over 1, so if you flip and multiply, that's 1 over 5x. Then what did we do?
Split it up.
Okay, so I could put the sine 4x here. I don't really want the cosine with it, so I'll just put it over here. This one has a 5x. I don't need the 5 anywhere, but I do kind of need the x. So could I just slide it over here?
Yeah.
Then what else do I need to add into my problem?
X.
I have an x because I moved it over.
Oh.
This has to be a 4x, so we need the 4 on top somewhere. So as x approaches 0, sine 4x over 4x would go to 1. And this is 1 over the cosine of 0, which is 1, times 4/5. And we get 4/5. Is that one okay? Let's try one more like this. Ideas. Can I just break apart the bottom? No, that won't work.
You separate to like theta over 1 plus cosine theta.
We could separate one of those thetas off. Do we have a formula for theta over 1 plus cosine theta? No. Happen. So our strategies, we kind of have talked about rearranging, breaking things apart. Something else we sometimes do is multiply by the conjugate. So I'm just going to leave the top as theta squared 1 minus cosine theta for a moment. On the bottom, I get 1 minus cosine squared theta. What is 1 minus cosine squared?
Sine squared.
So if I break apart theta squared, theta times theta, sine squared is sine times sine. So theta over sine theta is 1. what is 1 minus, what's the cosine of 0? So this whole thing turns into 0 anyway. All right, so that's a couple limit problems. Are those okay? Then the derivative problems, you just have to remember to do product and quotient when necessary. Let's recap the function and the derivative. So what's the derivative of sine x? What's the derivative of cosine x? Okay, what is the derivative of tangent x? Secant squared x. What is the derivative of cotangent x?
Cosecant squared x.
Remember, all the cos have a negative derivative. All right. What is the derivative of secant?
Secant x tangent x.
And the derivative of cosecant?
Cosecant x cotangent.
Negative cosecant x, cotangent x. You have to know these. So study those, make yourself some flashcards. The derivatives on the quiz won't be too difficult as long as you can do those. And you might have to do them within like product and quotient rules. You know, I might give you something like, what did I said? You guys don't pay attention. Say 3x plus cosecant x over tangent x. No, it doesn't have to be nice and pretty. And when do these trig functions all have nice, pretty derivatives when I do them? No.
It gets ugly.
It gets ugly. So, what do I have to do this derivative? Quotient rule. So quotient rule is low, d high. So the derivative of the top. What's the derivative of 3x? Plus the derivative of cosecant x.
I'm getting fed up.
With lead pencils.
Yes.
At least with the wooden pencil, it's not a surprise when it's done. You know it's coming.
Yeah. They just don't stay sharp long enough.
Low d high minus high d low. What is the derivative of tangent x?
Secant squared x.
All over low square. I'm not going to make you get too crazy with simplifying on these. I'm not going to say it's like a trig identity. You have to change to sines and cosines. So if we distribute, now we could do something here. What happens if you take a tangent times a cotangent? They cancel because those are reciprocals. On this one I need to distribute the negative and the secant squared. And this certainly isn't pretty, and it could be simplified more if we went to sines and cosines, but I will let you leave your answer like that. Okay, so just product and quotient rules still exist. We still have to use them. You just have the trig functions within there. So make sure you know those 6 derivatives.
Why is tangent x times negative cosecant x not cosecant tangent?
Okay. So it's tangent times negative cosecant cotangent. And I just recognize
Oh.
tangent and cotangent are reciprocals and they're gonna cancel each other.
I was not reading that those were together.
Other questions? So I have a review for you. Time to work. Quiz tomorrow.